Angie, welcome to another video. And for today's video, I'm going to present you my summary for chapter 7 in Cisco. So, before that, I'm going to open my NetAcat for the introduction. So, chapter 7, which is IP addressing. So, for the introduction, addressing is a critical function of network layer protocols. Addressing enables data communication between hosts regardless of whether the hosts are on the same network or on different networks. Both Internet Protocol version 4 are the IPv4 and Internet Protocol version 6 are the IPv6 provide hierarchical addressing for packets that carry data. Designing, implementing, and managing an effective IP addressing plan ensures that networks can operate effectively and efficiently. So for this overall summary for the introduction, this chapter examines in detail the structure of IP addresses and their application to the construction and testing of IP networks and subnetworks. So let's look at the topics under chapter 7. So for chapter 7, we have here binary and decimal conversion. Under it, we have IPv4 addresses, positional notation, binary to decimal conversion, decimal to binary conversion, decimal to binary conversion examples. Then under IPv4 address structure, we have network and host portions, the subnet mask, logical A and D, the prefix length, network host, and broadcast addresses. Then using the Windows calculator with network addresses, converting IPv4 addresses to binary. Then under unicast, broadcast, and multicast, we have static IPv4 address assignment to a host, dynamic IPv4 address assignment to a host, so static and dynamic. Then IPv4 communication, unicast transmission, broadcast transmission, multicast transmission. Then under types of IPv4 addresses, we have public and private IPv4 addresses, special user IPv4 addresses, legacy, classful addressing, classless addressing, assignment of IP addresses. Then under network addresses, IPv4 issues, the need for IPv6, IPv4, and IPv6 coexistence. Then under IPv6 addressing, we have IPv6 and address representation. Rule 1 and Rule 2 omit leading OS zeros, omit leading zeros, omit all zero segments. Then under types of IPv6 addresses, IPv6 address types, IPv6 prefix length, IPv6 unicast addresses. Then IPv6 link local unicast addresses. And under IPv6 unicast addresses, we have a structure of an IPv6 global unicast address, static and dynamic configuration of a global unicast address, then the dynamic configuration of SLAAC and DHCPv6, then EUI 64 processed and randomly generated dynamic and static link local addresses, verifying IPv6 address configuration, and then for multicast, we have assigned IPv6 multicast addresses, solicited node IPv6 multicast addresses, then connectivity verification. Under it, we have ICMP, then under it, ICMP-v4 and ICMP-v6. Then ICMP-v6 router solicitation and router advertisement messages. Testing and verification, testing the local stock, testing connectivity to the local LAN, testing connectivity to remote, trace route. Then for the summary, there are class activity, the Internet of Everything, the Packet Tracer Skills Integration Challenge, and the IP addressing. So let us see my PowerPoint presentation, IP addressing. So this chapter began with a look at the basics of the boot process of a Cisco router. Next, the initial configuration of a Cisco router from the system configuration dialog prompts was explored. Extended setup mode was used to assign the router its initial configuration parameters, including a host name, passwords, and interface addresses. Configuration from the iOS command line was looked at next, beginning with the process of logging into and out of a router. The differences between user and privileged exec mode was discussed, including how they can be identified by their associated command prompts. Next, a look at the configuration files on a Cisco router outline. The differences between the running configuration stored in RAM and the startup configuration stored in NVRAM. The syntax for the copy command was also looked at, including its use in saving the running configuration to the startup configuration. An overview of iOS shortcuts explained navigation techniques that can be used from the command line, as well as the use of truncated or shorthand commands. A look at the terminal store command explained how to change the buffer size or disable it within a session. Next, the iOS help function was explored next, including the ways in which it can be used to find or complete commands. A look at iOS configuration modes introduced global configuration mode, as well as the difference between the configure terminal memory and network options. Various levels of global configuration mode were also explored, including those associated with interface line and routing protocol configuration. The router prompts associated with each were also explained. Then, the configuration of passwords was also looked at, including the purpose and configuration of enable secret, console, auxiliary, and virtual terminal passwords. The service password encryption command was also discussed as a way of encrypting passwords not usually encrypted by default. The ability to configure a logon banner was also explored using the banner MOTD command. The, the interface configuration section outlined the procedure for setting IP addresses on interfaces, as well as the importance of the no shutdown command. An overview of configuring serial interfaces as DCE for lab environments was also discussed. The procedure for enabling and configuring IP was also looked at, including the configuration of Ethernet encapsulation settings for IPX. The show interface command was discussed as a way to gain information about an interface, including its physical and data link characteristics. A look at host names explained how to change the host name on a Cisco router, configure a host table, and finally how to configure a router to use a DNS server for name resolution. The copy command was then looked at in more detail. It explained the backup and restoration of configuration files and iOS images, both between memory areas and via a TFTP server. A look at a telnet explained the basics of initiating, disconnecting, and switching between sessions. Configuration of the router via a web browser was also briefly explained. Diagnostic utilities were looked at next, including both ping and traceroute. A look at the Cisco Discovery Protocol followed, including how it can be used to gain valuable information about neighboring Cisco devices. So, for the subnet mask, IPv4 address is a unique IPv4 address of the host. Subnet mask is used to identify the network or host portion of the IPv4 address. Default gateway identifies the local gateway. So, local router interface IPv4 address to reach remote networks. For IPv4 communication, unicast is the process of sending a packet from one host to an individual. Broadcast is the process of sending a packet from one host to all hosts in a network. Multicast is the process of sending a packet from one host to a selected group of hosts, possibly in different networks. For IPv4 and IPv6 coexistence, dual stack, it allows IPv4 and IPv6 to coexist on the same network segment. Dual stack devices run both IPv4 and IPv6 protocol stacks simultaneously. Tunneling is a method of transporting an IPv4 packet over an IPv4 network. The IPv6 packet is encapsulated inside an IPv4 packet, similar to other types of data. Translation is a network address translation 64. Allows IPv4-enabled devices to communicate with IPv4-enabled devices using a translation technique similar to NAT for IPv4. An IPv6 packet is translated to an IPv4 packet and vice versa. For IP addresses types, unicast is an IPv6 unicast address uniquely identifies an interface on an IPv6 enabled device. As shown in the figure, a source IPv6 address must be a unicast address. Multicast is an IPv6 multicast address is used to send a single IPv6 packet to multiple destinations. Anycast is an IPv6 anycast address that can be identified to multiple devices. A packet sent to an Anycast address is routed to the nearest device having that address. Anycast addresses are beyond the scope of this course. So, that is my presentation for chapter 7 summary, IP addressing. Thank you for watching and see you on my next video. Bye!